So thank you, Greg, for that kind introduction, and thanks to the forum for the chance to share some work with you today that I've been doing. This is actually joint work. So this is what happens when a criminologist and a statistician get to talking. So all the work that you'll hear about is joint with Seth Flaxman, who is now at Imperial, but was at Oxford when we did this work. And this work is summarized and has appeared in two papers. For those of you who are curious and want to know more, one is a piece in the Journal of Quantitative Criminology, and the second is a hopefully soon to appear paper that resulted in our winning submission to the NIJ real-time crime forecasting competition. So the work's reflected in both of those. So I want to start by explaining a bit of a puzzle to you. And it's going to take me a minute to get into the puzzle, but hopefully you'll bear with me. So we see in practice with firearm violence, particularly interpersonal firearm violence, sort of a nesting distribution. We have fatal shootings, which are a subset of all shootings in which someone is injured, i.e. someone has a hole in them as a result of a firearm discharge. And that is a subset of an even larger distribution, which is all discharges of firearms aimed, however imperfectly, at other people. And this is usually what most criminologists are talking about when we're focusing on interpersonal firearm violence in US cities and communities. These shootings are not random by any stretch of the imagination. They're clustered within lives, and they're clustered within place, and they're clustered within time. Now that has given rise to an entire literature in both criminology and public health, exploring the possibility that firearm violence, due to that extreme clustering, is actually a diffusing or contagious process. Something where one shooting will lead to another, if not multiple other shootings, themselves clustered in space and in time, and possibly also within social networks, something we heard alluded to in previous presentations. And I've just thrown up a few sites here. If you're curious, I have, at the end of the presentation, I have sort of a full reference list, but this gives you a flavor of some of the different scholars working in criminology. There's more public health, a nice NRC report on this basic possibility. Now, the puzzle comes here, which is we have another source of information about sort of the nature of these interpersonal shootings. And besides the NCVS, the other way we understand the motives behind shootings is that many urban police departments in America each year will publish something they'll call either a murder report or a homicide report. This is a statistic taken from the Metropolitan Police Department here in Washington, D.C., their murder report, which basically classifies among those homicides that are cleared, that means either solved by arrest or solved by exception, what does the police department believe the motive behind that shooting to be? And what you see when you look at these murder reports is that instead of seeing a preponderance of shootings being a result of this sort of retaliatory cycle, which is the most consistent cycle we would expect if we saw an epidemic-like phenomena, we see that a split that looks a little bit more like this, 0.86 to 0.14, non-retaliatory shooting to retaliatory shooting. So what are these other motives for shootings? Well, these other motives can be things like an argument. That could be an argument about that occurred at a bar. That's very typical in Philadelphia, where I'm from. Or it could be an argument involving a failed drug sale as well as a basis for a shooting. So we have this interesting puzzle, which is we have this large literature at this point that says shootings are diffusing, they're an epidemic, they're contagious. We therefore need to figure out interventions that match with that diagnosis of this nature of the process. And we have a second literature, or second set of statistics that says, well, a lot of them are much more random than that. You know, it's not clear that exactly how much of a follow-on spread we should expect to see. And so because of this sort of seemingly puzzling set of findings, Seth and I started out to try and figure out how we could go about distinguishing between these two sets of statistical patterns, particularly when we look at spatial temporal data on firearm violence. Essentially, the question for our research was, is gun violence contagious, or is it merely just non-randomly clustered, as we might find with other sort of clustered phenomena? And our particular contribution is that we have tended to use a series of spatial temporal models, including Hawk's models, as well as using some newer forms of data, like AGLS data that was described a little while ago, to try and tease apart these different phenomena.
Can you spell out what?
So AGLS stands for acoustic gunshot locator systems. They originally developed by the military and now deployed as a civilian version in many U.S. cities, predominantly by ShotSpotter, but there are other vendors that produce similar systems. Okay, so this is a very typical statistical test that we saw a few years ago using the Knox test, for those of you from spatial statistics, to try and look for non-random clustering of a phenomena, and in this case, non-random clustering of gun violence. And the scholars, these gentlemen are from Temple, used the Knox test and found that there was definitely a rejection of the null hypothesis. There's definitely non-random clustering. They have sort of these clustering in about 2 weeks and about 400 feet as what they saw in their findings. And as a result of that, this is sort of a typical sort of evidence that would suggest that we have a situation of potentially contagious violence. Now the challenge, of course, is that all that they found really is that it's clustered. So now we need to figure out how do we distinguish between these different forms of clustering. So now we're going to look at data from DC. So this is shooting data from DC, looking at a macro time scale, so years 2010 to 2012. We see huge spikiness in our data associated particularly with July 4th and particularly January 1st in this data series. But we could look at clustering also within a day of week. Hugely variable, but very predictable, clustering within time, peaking right around midnight in terms of shootings per hour. And if we look at it by space, we can also see a huge amount of spatial clustering for the District of Columbia. For those of you, we have Northwest over here, almost none, and then we start to see over in Anacostia quite a bit. Capitol Hill used to have quite a bit on the edge of Capitol Hill as well. So we have a lot of clustering going on. And when we look at the combination of space and time using something like a K function, we can see what we would expect based on that spatial and temporal clustering, which is a small number of places with a high amount of violence, and then most places having virtually none or a small amount. So with this basic pattern, we realize that it's quite implausible to assume that that a null hypothesis of complete spatial temporal randomness is reasonable. But then we have to ask the question, what's a reasonable alternative? And so what we tried to do in this work were a few things. First, we tried to bring in some new data because of concerns about missingness. So if you're not using this sort of newish data of AGLS data, which is sort of represented here on the right side of this chart, you're probably using calls for service data. Calls for service data is just individual civilian or sworn law enforcement officer who is calling 911 and saying, I think I heard a gunshot, or I know I heard a gunshot. And I may know exactly where it happened, or I may know approximately where it happened. So this is another form of data that we're going to be using. And this form of data has its own sort of error structure. There's obviously missingness associated with it, but there's also error in the form of when a civilian, the times I've called in gunshots, I could not tell the dispatcher exactly where the gunshot happened. It happened somewhere close enough for me to hear it, which may not be entirely useful. But you can already start to see a couple patterns here in these two charts. The first is that we generally have a lot more observations when we're using AGLS. That's oftentimes seen. But what I want to call your attention to in these sort of bottom charts here is not only that the levels are different, but in particular if you look at the right-hand side over here, you'll notice that the trends are quite correlated with each other. There may be some sort of leading lagging structure to it, but these are actually pretty, they're pretty much describing the same phenomena, but perhaps at slightly different levels. And that's something that in our work we've actually found that when we're using these models to separate contagion from just non-random diffusion, that we're seeing that you could use AGLS data or you could use firearm assault data from 911. They're going to tell you usually about the same thing, at least for the models we've been fitting. And these were the models that we used. The basic intuition that we had is that we wanted to fit a underlying background intensity that was not random, and on top of that have a second model for a conditional intensity with the intuition that some number of times this background intensity process would trigger this secondary conditional shooting event, and that we wanted to essentially partition all of the shootings that we see in space and time into these two components, the background intensity and a conditional intensity that we think is more likely a reflection of some sort of secondary process. Now, when we do this, what became very interesting to us, at least, was the fact that we would see a few things. So here we're looking at sort of the spatial intensity, conditional intensity, the temporal conditional intensity, and then the sort of equivalent of a K function of the space-time pattern. So when we looked for Washington, D.C., both using the ShotSpotter data, which is what D.C. had, as well as their calls for service data, we saw that the endogenous intensity, that background intensity, explained almost 90% of the shootings that were happening in Washington, D.C. And that only about 11% of the shootings seemed to be consistent with one of these sort of triggered or conditional intensities. The third bullet point there just says that, interestingly, this is pretty similar to the motive split that we saw when we looked at the Metropolitan Police Department's homicide report. They attributed about 84% of their shootings to some sort of argument or non-retaliatory basis, and only about 16% did they attribute to a sort of retaliatory or some sort of other consistent with contagion hypothesis. The length scale that we saw for those conditional shootings was very short. It was only about 12 minutes, so we think this is more consistent with the idea of actually capturing an ongoing gunfight than some sort of longer retaliatory cycle. And the spatial length scale was also very short as well. So in general, when we looked at our results, we said, this is much more consistent with a non-retaliatory basis for much of the gun violence that we saw in Washington. But because I was coming here, and I knew there were going to be some people from Chicago here, I bothered with Seth to do some additional analysis, not shown in our papers, to try and figure out how well these results generalize to other places. Right? We only had time to look at one other city, so I picked Chicago, a former Chicago resident. So I'm not picking on Chicago, but I was particularly curious to look at Chicago because Chicago has a very different violent structure relative to Washington, D.C. It's a very different gang structure as well, and so it seemed like a very interesting place to compare our results in practice. And this is one last graph just showing the sort of relative proportion for DC of those background intensity in blue, and in red, sort of this conditional intensity of these triggered events in practice. So we refit our models using calls for service data from Chicago for ag bats. This is just something taken from the Tribune that shows the ratio of fatal to non-fatal, fatal being in red, non-fatal in blue. They have a very nice app if you're interested in it. And what was very interesting to us is we saw almost the completely opposite pattern for Chicago than what we found for Washington, D.C. So when we separate the ratio of background shootings to these conditional intensity shootings, what we see is a split that suggests the background account for just under 25% of the shootings of the ag bats in Chicago, aggravated batteries with a firearm, and almost 76% of the shootings appear to be in these sort of triggered events that are conditional on past events. Not quite as consistent with the motive split, but broadly consistent. When we look at the CPD for, at this point, I think 40 years, has published a homicide report showing of those solved cases or cleared cases, what the motives are. They have a similarly flipped ratio, attributing about 34% to non-retaliatory shootings and 66% to some form broadly defined of retaliatory shooting in practice. We also saw very different length scales. In terms of time, 72 days was the average length scale. The results are a bit different if you look at 2016 versus 2017 and 2018. We're looking at all three. And the spatial length scale is much greater than what we saw in practice when we were looking in Washington, D.C. So much more consistent with the idea that you could have extended retaliation than what was observed for Washington, D.C. So now a few sort of takeaways from our work. First is that in general, when we look at this statistics literature on understanding the phenomenon of gun violence, particularly within cities, we need to recognize that life is not spatially random, and neither is gun violence. And so we need to move away from using sort of complete spatial temporal or spatial and temporal randomness as a reasonable null hypothesis. But that generates a lot of problems for figuring out plausible alternative hypotheses. The second point I have up here is just that we've developed one approach for understanding the difference between sort of an endemic phenomena and more of a diffusing phenomena. For the first city we tried it on, it suggested that most gun violence was endemic to certain areas at certain times and less reflection of a contagion type phenomena. But as I've just showed you, other cities may have a very different phenomena. And in future work, it would be very interesting to consider the question of a city like Baltimore, a city like Los Angeles, cities like Atlanta. To what degree do they fit into either of these two somewhat extreme cases that we've observed so far using these methods? I think another interesting question, I know there's a form on gun violence, but to be mildly provocative, I do like to point out, in the press right now in London, there is near hysteria over the issue of knife crime and knifings, and very similar rhetoric about the nature of knife crime as a contagious phenomenon leading to particularly young men arming themselves out of fear of victimization, which then leads to additional use of knives in the future. To what degree do our models, be they statistical or other models, that work in understanding gun violence, would they port onto these other related phenomena? Or do we think that gun violence in U.S. cities is sui generis to other forms of violence? Obviously, there's related concerns about contagion involving mass killings, and there's a lot of modeling work in that space as well. I think the last thing I'd say is, we developed this particular approach as one solution to the problem of modeling underlying intensities. Are there others out there that make perhaps different assumptions and come to different conclusions? I'd say the answer to that is definitely, but we hope to sort of begin the conversation about some of these different approaches that we could be using that supplement some of the more classical approaches in spatial temporal statistics, NOx, K-function, that have served us very well in other areas of spatial temporal statistical applied problems, but I think may not be perfectly well suited to something like gun violence. So with that, thank you very much.